Again, good afternoon. My name is Steve Watkins. I'm the elementary math coach for the school district here, and I work with teachers to support them. I work with students, and it's a lot of fun. So I support a lot of the math programs for the Queen Creek School District. And thank you, Chastity, for having me here today here at KMBE, and I'm excited to offer this for you all today. Parent Institute, I started a few years ago as a passion for mine when I stepped out of the classroom. And I remember having conversations with my students and say, hey, mom and dad told me to do it a different way. Mr. Watkins, you said do it this way. And parents would call me and kind of share with me about some frustrations. And I said, hey, and when I walked in and stepped into this position at the district level, I made it a priority of mine to help communicate to parents the why and the how of that we teach math in today's classrooms. So it's important to me that there's not this frustration at home. And that's really my why behind this, is to support you all, not to have you doing all the teaching, but support you supporting your student at home. So I'll dive right in. This Parent Institute tonight is focused on grades K2. I like to do a little icebreaker. I really truly believe this. The more you understand math, the more you understand the world. So again, you have to be odd to be number one. You have to do things differently to be first. All right. My favorite one, parallel lines have so much in common. It's a shame they'll never meet. Womp, womp, womp.
Math jokes.
Math jokes. I have to get it going. All right. Real quick, one important thing for our school district is our mission. And our mission in Queen Creek School District is to empower each student to achieve excellence in all pursuits and lead with integrity. And I think it starts here. I think it starts with having parents that not only are engaged, but supporting their students. And you're doing that by coming to this tonight. Okay? And it all leads to student success. The more that we're involved, the more that teachers are knowing, it's going to lead to better student success. And that's why we're here. So again, let me get back to my why about why do we have this Parent Institute. Follow along in your notes. I have these. Feel free to take some notes along with me. The goal of Parent Institute is to help support your child with math instruction. Not to do it all, but to support. We want you to work alongside us educators. Familiarizing yourself with new teaching methods will help bridge the gap between them and traditional teaching methods. Right? So most of you all learn traditionally like I did in school, and it looks a lot different. We have a lot of manipulatives, a lot of visuals to help them understand. So a big shift in teaching math today is a greater focus on understanding concepts and less on memorizing steps and procedures. I remember being in school, if I could follow the steps, I was going to do well. Do this step, don't ask why, just do it. And memorizing leads to forgetting. There's so much that I've forgotten. Understanding leads to application to novel situations. So if I can give you true understanding, true meaning of that, hopefully you can apply it to new situations outside of what's in the classroom. And that's what we really want as educators. All right. Just a little brief overview of what we're going to talk about. I'm going to talk about the larger domains of what kindergarten through second grade students see. I'm not going to get into a whole lot of the telling time. A lot of that hasn't changed. I'm not going to get into measurement a whole lot as well. But I'm going to focus on some of the larger ones today. We're going to talk about 10 frames and why those are important. Number lines, what does doubles mean? Base 10 number system, maybe you've heard of the H2O chart from your students. And partial sums and differences, and then using the bar model to support word problems and multiplication basics. Before I move on, are there any questions? Any questions from virtual? Feel free to type those in. All right, any questions? All right. The first thing that most students see at the kinder level to understand our number system is a 10 frame. And I have some up here on the whiteboard that our first grade teacher brought in for us, but a 10 frame is an array of squares that can be used to visualize numbers really 0 through 10. And they're going to focus on this understanding. The standard calls for them to have an understanding of number pairs. So for example, is that this is 10, and I can see it as different ways. And we're going to look at different examples in that in just a moment. But here I have 5. So they start learning these different units, that a 10 is 2 5s. And that's where this idea of number sense starts. And they're going to use this tool of the 10 frame throughout many different standards throughout kindergarten and first grade, building these foundational skills. So if you see a 10 frame, is to help them understand the units of 5 and 10 and other numbers and how they relate to each other. Here's an example. So a student is expected to see the number 7 as part of it is 5 and the other part is 2. And I can use that. I can change the colors for that on these as well to help them understand that. But also, 7 is not just 5 and 2. A student needs to be flexible with their thinking to see that it's 4 and 3. I still have the same value, but part of it's 4 and part of it's 3. When I start with 4, the other part's 3. Maybe it's 1 and 6. Those are just different ways that they can start being flexible with their understanding with the value of 7. So these are some of the foundational skills and knowledge that our kindergartners are building when they're using the 10 frame. I've been into some of our classrooms here at KMB to work with students on that. So I'm going to ask, how do you see 6? If you're out virtually, feel free to type something in. What are some different ways that we see 6? Teachers, I'm going to call on you as well.
3 and 3.
3 and 3. Let's see. This may not work. All right. Not going to work. Too many things going on. So 3 and 3. How might you see it?
3 times.
Yeah, exactly. 2, 2, and 2. Exactly. So again, that flexibility with it. We want students to understand that. All right, anything virtually?
Nope.
Okay. All right. Once they start getting more familiar with the 10 frame, they're going to start adding. They're going to start with their first operations. And in this operation here, I have 8 and 4. So what they're going to first do is they're going to start counting all of it. So the progression of counting is we're going to start with counting all. What you may see your child doing in preschool and getting ready for kindergarten, you're going to have to see 1, 2, 3, 4, 5, 6, 7, 8, and then counting all again. 9, 10, 11, 12. That's counting all. The next piece, the next progression from counting all is counting on. And what that means is I understand that I have 8 here. I can keep that in my head in my working memory. 9, 10, 11, 12. I'm counting on. And they're using a manipulative for that. Okay? So that's going to help them with that counting on piece. It's natural to count on your fingers as well. That's okay. That they're becoming more familiar with using a tool to help them familiarize with counting on. All right? So we're going to use a 10 frame for that. The second piece is to continue counting on, is to use a more abstract idea of a number line. Yeah, I can do the same thing, what I did with manipulatives, but I'm moving to a more abstract tool that's going to use in other grade levels. So this is the number line. I'm going to start at 8. And just like I did with the manipulatives in the 10 frame, I'm going to continue to count on. So 8, 9, 10, 11, 12. And when they start at 8, hopefully they are at the counting on stage instead of counting all. And it's very natural at early stages of development that they're counting all still. And so that's okay. So this is what it looks like through addition on counting all and adding on. Also, we can use the 10 frame for subtraction. Just like we were counting on, now we're going to count back. So I have 13 here. The student's going to see this as 1 10 and 3 1s or 13 1s. They can see that. So they're going to use this tool to help them understand. So they would cross off 5 of them, and they would tell me that they have 8 left. So I count it back. So if it's counting back, 12, 11, 10, 9, 8 are left. Okay, so naturally I'm counting back, I'm doing the opposite. And just like before, when we were using the manipulatives with the understanding of counting back, we're going to move to the tool of subtracting using a number line to help us count back. So I'm going to start at 13 and I'm going to go back the same way, but we're putting in tools at the appropriate time that they're developmentally ready to count back. And again, they're starting at 13 here and counting back 5 for subtraction. Any questions so far on using the 10 frame and or the number line for adding on or counting back? Yes.
When do they start, like, is this?
The subtraction, they're going to probably start this in kindergarten.
When do they start counting back?
Counting back, yes. And again, you're going to use the pictorial or the concrete example. So we have these here. Teachers are using these. Students can draw these. They might even have their own set to show that. So if they're using this, they would just kind of pull them all for counting back.
Got it.
All right. What I like to do with instruction is do the drawing and the number line at the same time to connect those.
Oh, okay.
All right. Good question. Thank you. All right. Moving right along. So another powerful strategy and tool for students that's very similar to the 10 frame is the number bond. So a number bond is a representation of 2 smaller parts that make up a whole. And this is something that they're going to use all the way up into 4th, 5th grade, this understanding of number bonds. They're going to use it with fractions, but they're building that understanding now. Earlier, I asked how you saw 6. Here, we're taking a look at how we see 10. Part of it's 3, part of it's 7, and the whole is 10. So we could have done the same way with 6. You said 2, 2, and 2. So that number bond would have been drawn out differently. So students use number bonds with adding strategies. Students will use this with making 10. So a lot of the focus in kindergarten is also with that understanding of making 10. So they were doing number partners from 0 to 10. We looked at 6, we looked at 7, but also become fluent with making a 10. Okay, students have been working with the idea of number bonds since they started with 10 frames in kindergarten. So again, you can do a number bond on the side with this to help them understand the 10 frame. Part of 10 is 3, part of 10 is 7. When those parts are together, the whole is 10. Okay, so part, whole is some of that language as well. Yes?
So I see that it says making 10. Can you use the number bonds with any number or just?
Yes, any number. So for example, if we were making 6 again and we said 3 and 3, so that number bond would be 6 as the whole part is 3 and the other part is 3. All right. And again, like I said, it's a great tool. So part of learning today is we want to put a tool in place that's going to go for a lot longer, for several grade levels. So I could put the number 1 up here, and I could do half and half because part of 1 is half and the other part is half. So it's a tool, like I said, that they're going to use in other grade levels, 3, 4, 5 as well. Yeah.
Have they, like, research or whatever, noticed that kids learn easier when it's drawn out like this versus the old-fashioned way?
Definitely. Especially, that's an excellent question, and that's one reason we're using concrete manipulatives.
Okay.
So you can understand things a lot that you can manipulate with your hands. So the progression is that you want to move things that are concrete to pictorial of representing. Okay. So it might be that I'm using this first to help them understand, and I'm moving to drawing it out, and then to the abstract. And the abstract would just be this number bond.
Okay.
All right, or an addition equation. So this addition equation would be 3 plus 7. That's very abstract. If I said here, just figure that out. But I want to start with, here's 3 things to count that are red plus 7 yellow. How many total objects do you have?
Right.
So you can either count all or count on.
Okay.
Okay, good question. So we definitely want to start with.
So more of a hands-on,
Yeah.
hands-on learning
Mhm.
versus just telling you how it is and then.
Exactly. Going back to my beginning, we want to build understanding that not just memorization, but a true conceptual understanding that can be applied to new situations.
Okay.
So if I gave you 3 and 7, what happens when I give you 4 and 6? Can you do that one now?
Okay.
Okay, so you say, hey, last time I just counted this, these manipulatives, so I'm going to do the same thing now, right? So again, this is the number bond. It shows parts of the whole. Any questions from the virtual audience?
Nope.
All right, thank you. Feel free to type those in. So we can use making 10. So once they become familiar with the number bond, they're understanding this relationship with making 10, and it's really helpful for adding. So I'm going to walk you through. Feel free to draw some notes on your paper. I'm hoping this works. I have a lot of software and programs running, so let's see if it's able to touch. If not, I'm going to walk you through. So earlier, they've had familiar with the number bonds. Will you adjust the camera? I'm going to actually go to the board so I don't have any issues here. Thanks, Shannon.
Of course.
So here, we have the same thing on our whiteboard as what we have on our presentation. So I have 7 plus 5. And students have become familiar at earlier parts of their development stages that I can make 10 here. So with adding, I can shift 7 to make 10. So they recognize that 7 is here, and I have a little bit more that I need. So they see that 7 needs how many? And they're going to say, well, it needs 3, correct? So over here, I can take these 3. And I made 10. And adding 10 is very friendly, isn't it? Very friendly. So I did not add all of 5, so now I have to add the rest. So now I have 12. When they became more familiar with making 10, they're able to use other strategies when they're in first grade to add very fluently. Okay? Thank you, Shannon. All right, so let's do one more. Oh, this one that allows you to fill it in with me. So I'm going to set this one up. I'm sorry, Shannon.
Nope.
Thank you. So I'm going to set this one up again. So 8 plus 6. And just like I said earlier, we're using those manipulatives to support that understanding before we go to a drawing and before we do it abstract. Sometimes it's very beneficial to do the abstract equation alongside with it so that when they're doing it later on just in the abstract, their mind can go back to what they were visualizing. So here I have 8, and my job is to make a 10 so that it's easy to add. So let me model that again for you. Feel free to draw it in if you would like on your notes. 8 plus 6 equals a question mark right now. And my job is to make a 10. So over here, I need to shift over here. So I move 2. The other part of 6 that I did not move is 4. So now I see that my 10 frame is complete. Plus the 4 that did not shift over to fill in my 10 frame is left. I have not changed any values up there. I'm just being flexible with how I see the numbers. So now 8 plus 2 gives me that complete 10 frame, or a 10, plus the 4 left over. So now my question mark is 14. All right, Julie, is there a question?
No.
No? Okay. Questions from the audience?
I wish I learned this one.
You like this? Yeah. And again, this is the foundations of it, but they're going to be doing some similar things later on in other grade levels. And we want to build that and keep growing that understanding of being flexible with numbers.
Now, has the old-fashioned deals gone away completely?
No, that's a good question. The question was, do we still teach traditionally, correct? Since that question's brought up, the traditional algorithms for addition and subtraction are expected to be taught in 3rd grade and to become fluent with it in 4th and 5th grade. Same thing for teaching multiplication strategies. They're expected to be fluent with multiplication in 5th grade. And 6th grade is for division. So they haven't gone anywhere. There's just a time and place, and we want to give the how and why behind it in the flexibility tools prior to them becoming fluent with the traditional ways. All right, good question again. Thank you. So some of the other pieces that we've talked about so far are strategies to be flexible with numbers. One of the other things that's popular is fluency with facts, with math facts, 2 plus 2, 3 plus 3, 3 plus 5. And one good place to start with students is doubles. And I use dominoes, and that's something that you probably could use at home to help with addition. And one good place is doubles is to start. So I can see 3 plus 3 and this representational. So once they master their doubles, 3 plus 3, 4 plus 4, you may take a look at doubles plus 1. So doubles, so we have 3 and then 1 more of that. So if they know doubles, 3 plus 3 is 6, 3 and 4 is 1 more, so it has to be 7. So it's another way for them to become efficient and flexible with their understanding of math facts. So then if you know doubles plus 1, this does not fit anything. This is not an example of a strategy, 3 plus 0, so this is just 3. So we can do doubles plus 1 and doubles minus 1. So here's another example of some of those doubles to become fast. Most students are going to know their 5s right away. So 5 plus 5 is 10. Here's an example of doubles minus 1. So it would have been 10 if it was doubles, but I know that 4 is 1 less. So it cannot be 10, it has to be 1 less, because one of my add-ins is 1 less than a double. And then here's doubles plus 1. So 6 is 1 more than the double of 5. So I know if it was doubles, and I just add 1 more. And this is a great example of doing it pictorially with the abstract alongside with it. Okay, so it helps bridge all those connections. Here's some more examples of doubles and doubles plus and minus 1. So we have 4 and 3. All right, any questions on doubles? I'm sure if your students are in schools these days, you've probably seen base 10 blocks. And their base 10 blocks, again, they're using pictorially some concrete manipulatives to help them understand. So our number system is base 10. And it's important that our students start developing this number sense at an early age about the base 10 number system. And the majority of our standards through kindergarten through 5th, 6th grade are numbers-based system for them to develop this understanding. And not only is it whole numbers, but our same numbers system applies to decimals as well. But in the early grades that we're focused on today, we're going to focus on whole numbers. So we're going to use these manipulatives to help us understand. Most of your students would say, hey, I know what a 1 is. And just like they became familiar with using that 10 frame, once I fill up a 10 or make a 10, it takes 10 of these to make a 10. okay? It takes 100 ones, this base 10 system, it takes 100 of these to make a 100s flat. And they can visually see that. So they're starting to build this understanding that this is happening. And they've been doing this from kindergarten when they do calendar time and they're bundling sticks and they're counting the days that they've been in school. So it takes 10 tens to build 100 or the same value. And again, we're getting that understanding of flexibility with the number-based system here. And then also the understanding of what 1,000 is. It takes 1,000 ones, 100 tens, and 10 100s. And they can stack their blocks up and figure out how many it takes to equal this amount. Okay? But it's very important that they start understanding the value of our number system. Okay? So as they start developing this understanding and we're moving through this concrete representational abstract idea, they're going to start doing things in expanded form. So here I've drawn out 300s blocks. And that is 300. This is what we call expanded form, and it helps students work flexibly with their numbers and adding. So here I have 300 plus 40 plus 7. So this value is 347, but I just pulled it in something we call expanded form. Standard form is 300 in the threes in the hundreds place, 4 in the tens place, and 7 in the ones place. But we can expand it out. Here's what it looks pictorially. And then assigning the 7 in the ones place, we understand that it's 7 ones, 4 is in the 10, so it has to be 40, and 3 is in the hundreds place, so therefore it has to be 100. It's assigned that value. But when they start using expanded form, it's going to help transfer to other things they're going to do with larger numbers. Earlier, we were looking at other skills that they're doing with smaller add-ins, but now our add-ins are getting larger as we get more into second grade. Right, so if I was, let's see if it works out. Oh, yes. So if I was to build this one, I have 5, so the student would need to show their understanding. This is what we ask them to do, that's 500. Okay, and then 2 tens would look like this. Sometimes they're doing just straight lines. You may see this. Sometimes they're just drawing larger squares. I like to put a 10 frame in my H2O chart, or my hundreds, tens, ones chart to help with that understanding that they're making a 10. All right. Any questions so far on our number system? Pretty cool, isn't it? Yeah. So here's what it looks like for addition. So again, I still have this 10 frame in here, so I have 154 plus 38. And again, my job when I see that I have 4 ones and 8 ones is to make a 10. And we were using that and we're saying make a 10 because that's what we call borrowing, regrouping, moving over. And I'm going to show you what that looks like conceptually here. So my job is to make a 10. And I'm making a 10. It's not going to work. Do you know how to use this?
No.
No? Okay.
In my
All
room, yes.
It would make a 10. So this would come over here. I would cross this off because it's unstable. Because when I have 10 ones, it needs to be 110 now. I would draw a line here. And I would say that I have 2 ones. So I would count my 10s now. 10, 20, 30, 40, the one that I added that I cannot draw. 40, 50, 60, 70, 80, 90. Okay? And then I would count my 100s. So my answer would be 100, 9 10s, 2 ones left over because these made a 10 and I move that 10 over into the 10th place.
So that, I don't mean to interrupt.
No, you're fine. You're not interrupting.
So that's just like in the olden days when we were doing our deal. I'm going back
Yeah.
to the good old days. No. When we would do like that 8 plus 4, you bring down your 2, you carry your 1 over. You're basically doing that, but in the picture form. Right?
You know, you're gonna take my job, right?
No. No.
No, you're understanding. You're getting like, but you can really see what exactly right.
Okay.
Yeah, and that concept, boys and girls, you made a 10.
Right.
This is why it comes over here, because you have that understanding now that this is no longer 10 ones. We're gonna call it 110. And now I'm adding all of my 10s with the other 10s. Thank you.
Now this doesn't look too crazy.
No, it doesn't. Like, and that's again, that's my goal. It's like, hey, here's what we're doing. Here's why. Here's how it connects. That's why I call it bridging the gap. You're exactly right. All right. Thank you. So again, I can do it for subtraction. I'm going to see if I can draw this one because it's having a hard time doing that. So 34. I'm going to only want to put my first subunit in 34. And I have to take away 17. So I think this is going to be a connection with you as well. I'm asking to take away 7 ones, correct? Okay. All right. So here's what I'm going to do. I'm going to regroup this, and I'm going to exchange it now. This 10, I'm going to move over because that I know, and the child knows that this 110 is the same as. So it's going to look like this. Now I have 14 over there. Okay, right?
Can I just add in some
Yeah.
language, just for parents, if you see, like, when we're talking, you know, putting together, that's like our traditional, but we like to say composing, like we're trying to compose something and we can bring that into
Sure.
the music. You're composing, you're creating something.
Perfect.
And then when we do that borrowing or that regrouping, when we take it back apart, we're decomposing. And so bringing in that math language of,
Right.
you know, sometimes even just the language trips up the parents of like, I don't really know what this means.
Right.
But composing just means we're putting it together. Decomposing or taking it back apart.
So that's
So really
exactly what
using
she's
that
saying is
Makes
I decompose the 10 to 10 ones.
sense.
I could compose it back to 110 if I needed to, but in this case, I'm not going to need to.
Right.
So at this point, I can take away my 7 ones. And I see that I have 7 left.
Took away 8.
Took away 8. I knew it should be 7, right? And then I need to take away 110, correct?
Right.
So I have 110 left. So it's going to look like this. 17. All right. Because I have 110 left over, 7 ones.
Okay.
All right. And again, we're building that concept. I think I may have done that here for you in your notes as well, but I wanted to make sure to model it out. And again, in the notes, you can see that decomposing piece of the 10 and changing to 10 ones. All right. Any questions? All right, cool. We talked about number bonds, and I talked about how important they are. We're going to look into another strategy called partial sums. We're building upon what they're always doing or what they've already mastered. We're putting other tools that are similar to the ones that they already have in place. So this is called partial sums. We looked at expanded form. We looked at number bonds. So now we're going to start connecting them together for other strategies. So partial sums, just what I like to talk to students is part of the sum, part of the answer for an addition problem. So a way to add numbers by adding each place and combining sums. So here I have my number bond that 30 is made up of 30 and 4. So that's what it is in expanded form. And 20 plus 34 plus 25, so 30 and 4, and 20 and 5 are my parts for all of those. So what I would do is I would add all my 10s together, 30 and 20. Okay, so now I have part of my sum, or partial sum is 50, and then I need to add my 1s together. So 4 and 5 give me 9. And then once I have both parts, 50 and 9, I need to put them back together to get the total sum. So partial sum, part of it, and then total sum. And we use that. And here's what it can look like later on. So as we're moving to that traditional algorithm, I'm going to see this as 30 and 20, and I'm just going to say 50. Because they're moving to get to be more fluent in that traditional way. And then they can just 4 and 5 is 9, and they can say 59. It's the progression to that.
Okay, and just this leads really mental math, so they can visualize it, not have to try to do the borrowing in our heads, that they can start breaking it down.
Exactly, thank you. All right, here's another example. I wanted to show this example because there's an extra step in this. So here again, my number bond is 30 and 7, 10s and 1s in expanded form, and 45, 10s and 1s, my number bond 40 and 5. So I'm adding my 10s together. I have 70 plus 7 and 5. I have 12. I can either count on and say that's 82, or I can put another step. I can break it down into the 10 again. So here we have 37. I got my 10s. In this example, 37 and 45, I have 7 10s. Then I add my 1s, 7 and 5, I have 12. The next thing is I went and added my 10s again because it's easy, it's friendly. And then I added my 2, and I get 82 either way. Okay, and again, it's putting the necessary steps in place at early grade levels that they're building on these foundational skills now. Okay. So these are our partial sums, and you can do the same thing with partial differences. And I like to be flexible with this. And we're going to bring back that number line now. So in your notes, would you write 10 and 7 here? Again, I apologize. I'll work this out for next week for figuring out how to write on these boards. So 44 and 17. So partial, I can count back by 10. I'm going to take away my 10 first, and you see that on our number line. So when I go back 10, I'm just subtracting a friendly value, 10. I'm changing the 10s. So 44 goes back to the count. I count back by 10 to 34. And then I know that 7, I'm going to go to 30 because part of 7 is 4. And I'm just taking off the ones that I have in a friendly way. And then I have to do the rest of 7. I haven't done all of it. And then I count back to 27. And here we're connecting that back to what they can do on the number line. Right? Again, that tool was put in place in kindergarten, and this is more second grade right here. So that carried on. All right. Questions on partial sums and differences? I believe it's in second grade they start to do word problems a lot more, and they start to do things in kindergarten actually with word problems, but two-step word problems in second grade for sure. And this is a new thing called tape diagrams, or you might hear it called bar models. They're pretty much the same thing. And I have fallen in love with them to help understand word problems. So for example, I'm going to read the word problem, and I would traditionally set up my bar model based on the information that I read to help know what operation to do for it. There were 6 purple marbles, 4 red marbles, and 3 green marbles in a bag. How many total marbles were in the bag? So I'm going to do a section for 6, a section for 4, and a section for 3. And I know how many were there in all. So that would tell me to add on that one. So I'm going to create it. And then once I create it and figure it out, I'm just going to use the other strategies that have been put in place to add. Okay. There were 13 marbles in the bag. Okay. Here's another example. The last bar model or tape diagram was for addition. And this one's going to be for subtraction. Sarah has 5 fewer crayons than Jim. Jim has 9 crayons. How many crayons does Sarah have? So this is 9. I know that something plus 5 because Sarah has 5 fewer. It means he has 5 more. So this amount plus this amount equals 9. I can take away this 5 and I'm left with what Sarah has, just this box. So again, that representation with drawings is helping them understand. Take away the 5 and I'm like, okay, the blue box has to be 4. I'll go back and plug that in. I say 4, if Sarah has 4 and Jim has 5 more, it has to equal 9. Therefore, this box and this total length down here have to be the same size drawn for that to be an accurate statement. Okay. So these are bar models, these are tape diagrams, and they help support students with part, whole as well, also with those word problems. Okay. My last slide for this pretty heavy, and it's in 2nd grade that they start, at the tail end of 2nd grade, that they start to see the idea of multiplication. And really, they're starting to see it as repeated addition. So here we have our definitions of factors and product. So a factor is the numbers being multiplied. The product's the answer to a multiplication. So it really, to support your child or your student, you want them to see that it's 5 groups of 4 and the ideas of rows and columns. So here we have that. And we want them in 1st and 2nd grade, what they need to be mastering is that it's repeated addition. And that's where they pick up in 3rd grade. So today's been really kind of an overview, a 10,000-foot view of kindergarten through 2nd grade. But before I wrap up, are there any questions? Anything you would like me to go back over?
I would like to share as a 2nd grade teacher how this connects with other things that they're learning. For example, right now we're teaching money. And because they had such a good foundation in kinder and in 1st grade with the base 10 blocks, 10 frames, now when they see a quarter, 25 cents, they can easily put that dime, and they're able to skip count so much quicker, and they don't have to do the math 25 plus 10 on a paper because they can do it mentally, because all that time was spent on that abstract, the pictorial, the manipulative, that now they can actually count the money mentally without needing that. Obviously they use money, but it's very helpful in the later grades if you get that foundation.
Right.
Thank you, Ms. Onofre. All right. Feel free to shoot me an email or follow me on Twitter. I always share things that I'm seeing at KMBE. I share other things that I see at the other sites that I work at, but I really appreciate you coming out. Feel free to stay around and ask some questions for the teachers. If you're joining us virtually, thank you again. Please come next week. I'm going to be doing 3rd grade through 5th grade, and you're going to see how some of these tools and strategies transfer over to what they're doing in the upper parts of elementary. You can see kind of the whole picture of why we do things this way. So again, thanks so much for coming. I hope you guys have a good evening. Thank you.
Thank you. Thank you.
Need an escort back out? Are we able to?